7.2 is all about the property of rational exponents. But before we get to the property of rational exponents, let's talk about simplifying radicals. And I like doing this. This is kind of fun. How can math be fun, Smith? You're crazy. Simplifying radicals. Let's talk about that. First of all, let's kick it old school style. What is the square root of 18? Well, we used to go and make that tree because 18 is not a perfect square. What multiplies to 18? We could go 9 and 2. We could go 6 and 3. Whichever. Both ways work. You get 2 times 3. And in order to get out of radical land, you needed a buddy. So who's got a buddy here? 3's got a buddy. So a 3 comes out. 2 got left behind without a buddy, so he's left inside of radical land. So 18 simplifies to 3 root 2. But what if it gets a little funky? For example, let's talk about the cube root of 625. Well, what multiplies to 625? Well, it turns out 25 times 25 multiplies to 625. And 25 is, and 25, so it's a, oops, not 2, it's a bunch of 5s. 4 5s to be precise. Now, cube root land is a far more treacherous land than square root land. Where in square root land, you needed a buddy to get out. Cube root land, it's much more treacherous. You need 3 buddies. You need a trio in order to get out. So we got 4 5s down here, but we need a trio of 5s. And then only 1 5 makes it out. Then this 4th 5 didn't get a trio, so he is left behind in cube root land. So the cube root of 625 breaks down to 5 times the cube root of 5. Hey, let's go back to the square root of 18. What is the index of square root? If there's nothing there, there's actually a 2 there, and that's why we need 2 buddies in order for something to come out. Cube root land, you need three buddies. So how about the 4th root of 96? How many buddies do you suppose you need in order to get out of the 4th root land? You guessed it. You need 4. The index tells you how many buddies that you need. So tell you what, I'm going to pause it, or I'm going to keep talking, but let's do the 5th root of 32. Go ahead and pause this and try these 2 problems yourselves. Pause it, give them a shot. Ready, go. All right, welcome back. So hopefully for this one, when you made a tree, you got 2 and 48, 2 and 24, 2 and 12, 2 and 6. 6 breaks down to 2 and 3. So there's a whole bunch of 2s, and we need 4 of them in order for something to come out. And so you should have got 2 times the 4th root of 6. That was your answer for the 4th root of 96. And then the 5th root of 32, hopefully you just came up with 2. So, simplifying radicals. Awesome. Now, some other tools that we're going to need for these rational exponent rules is, we're going on to a new section here. First of all, you need your 7 exponent rules. We need to be ninjas at those. 7 exponent rules are 2 tricks associated with those. That's right, the bump trick and the who wins. But then there's going to be 2 more that go with that. And here are our 2 new rules. The nth root of A times the nth root of B equals, check it out, since they're both inside the nth root, inside the same houses, we can multiply them together and get the nth root of A times B. All right, and then we also have a second rule, and I'm guessing y'all can figure out what this one's going to be. The nth root of A divided by B is going to be, you guessed it, the nth root of A divided by the nth root of B. Awesome. If you ask me, these 2 things aren't unsimilar from this one. A times B to the n equals a to the n times b to the n. Where particularly, check it out, if this is 1 over n, they're each 1 divided by n, in which case it would be the nth root of a times b. See, that's where these are coming from. And this one is very similar to ab to the n power. You would distribute it to both of them. All right, so these two new rules really aren't that new. Those are two new rules. But those are going to help us for some problems that are about to come up. And we're going to be using exponent rules. Now, we got pretty good at this in the beginning of this chapter. But now that we got these nth roots and stuff, and we're using fractions, we're going to put a little bit of extra stink on it. For example, the first example here, we're going to do 6 to the 1/2 times 6 to the 1/3. That's our first example here. Now, which rule does this look like? This looks like a to the m times a to the n. So we're going to add those exponents here. So what's 1/2 plus 1/3? That's going to be 6 to the, if you use your calculator, you'll find 6 to the 5/6 power. Now here's one of the things though. Our final answer should not have negative exponents, nor should they have fraction exponents. So we need to rewrite this. And another way to rewrite this is the 6th root, the denominator is the index, the 6th root of 6 to the 5th power. Again, this is exponent form, this is radical form. Our final answer, we want it to be in radical form. All right, here comes a couple more. 2 and 3, let's go with 3 to the 5/3 times 3 to the 1/3. And let's go with x to the 8/3 divided, or excuse me, raised to the 1/7 power. Tell you what, pause it, chew on these for a minute, and then let's keep going. All right, so I went ahead and did these. You add the exponents, you get 3 to the 6/3, which reduces to 3 squared, which is, of course, 9. Hopefully y'all got that. If you did that, good work. However, number 3 is a little tricky. I ain't gonna lie. What are we gonna do with these exponents? We're gonna multiply. So we got x to the 8 21ths. Oh, I lied. This isn't as bad as I thought. So we got this, the 21th root of x to the 8th power. Very good. Now, check out these 3 problems, particularly the first 2. What did they all have in common? Well, check this out. Each one, the bases are the same. So there's kind of a little rule that we're going to follow here. If they have the same base, we're going to use, then use exponent rules. If they have the same base, we're going to employ our exponent rules here. All right, that's what happened here. They had same bases but different exponents, so we just used our exponent rules and did our thing. This one, while there's only one base, it's still the same base. And this one's kind of clear. We're going to use the exponent rules. But that brings us to 4, 5, and 6. 4, 5, and 6. Number 4 is going to be, let's kick it off old school. Let's go 8 times 5. Smith, that's too easy. 8 times 5, is there a trick to it? No. What's 8 times 5? It's 40. But number 5, let's go with this one. 4 cubed times 2 cubed. That one seems a little bit different. Now, we could do 4 cubed, and 4 cubed is 64, times 2 cubed is 8. We could do 64 times 8, but I don't want it. That's too much work, actually. Let's go back to number 4. When we did 8 times 5, what's the exponent on 8? Even though you can't see it, there is a 1 there. And the exponent on 5 is also a 1. So 8 to the first times 5 to the first is 40 to the first power. So check this out. As long as they have the same exponent, we can employ that here. 4 to the third times 2 to the third is going to be 8 to the third power. 8 to the third power. So I'll tell you what, here comes 2 more. 18 to the 1/4 over 9 to the 1/4. Try that one, and try this one as well. 27 to the 2/3 over 9 to the 2/3. Quantity to the 8th power. Go ahead and pause it and try these two. All right, so 18 to the 4th divided by 9 to the 1/4. We got 2 to the 1/4, but remember we don't want fractional exponents. Final answer is the 4th root of 2. Now, 7, this is where it gets a little bit tricky. Hopefully y'all came up with 3 to the 2/3 power raised to the 8th power. Which is, then with these, we're going to multiply the exponents to get 3 to the 16/3 power. Which is the cube root of 3 to the 16th power. Now, let's think about this for a minute. What does 3 to the 16th power mean? 3 to the 16th power means 3 times 3 times 3 times 3 times 3. Hopefully that's 16, I think. I think it's 16. So that means there's 16 3's being multiplied here. But let's try and simplify. If we want to get out of cube root land, how many buddies do we need? We need 3 of them. So check this out. There's a group of 3. There's a group of 3. There's a group of 3. Group of 3. Group of 3. How many group of 3's do we got here? We have 5 group of 3's. So we have 3 to the 5th power. And who got left behind? 1, 3. So this is 3 to the 5th power times the cube root of 3. That's going to be our final answer here. All right, so that kind of brings us to a new rule. If they have the same, well, what did all these have in common? They had the same exponents. Check it out. 4 to the 3rd times 2 to the 3rd to the 3rd. Even this first one. To the first, to the first, to the first. If they have the same exponents, then we can multiply or divide the bases. If they have the same exponents, then we can multiply or divide the bases. All right, so that brings us to our last section here, and that's called rationalizing the denominator. Rationalize the denominator. Let's go old school. 6 divided by the square root of 3. Somebody decided you're just not allowed to have a radical in the denominator. So in order to fix that, we got to multiply the top and bottom by root 3, and we would get 6 root 3 divided by 3, which again reduces to, that's right, 2 root 3. We've done that before. But here's where it gets a little bit tricky. What if I give you the 5th root of 7/8? All right, so a couple of you have already caught on that, hey, I can use one of those new exponent rules. We got the 5th root of 7 divided by the 5th root of 8. Awesome. But here's the thing. What's another way to write 8? Another way to write 8 is, I'm thinking exponents. This whole chapter we're trying to think in exponent form. Another way to write 8 is 2 to the 3rd power. Now, in order to get out of 5th root land, running out of time here. In order to get out of 5th root land, you need 5 buddies. We only have 3. That means we need how many more? This is 5th root land. We need 2 more. 2 squared and 2 squared. 2 squared, of course, is 4. So this is the 5th root of 28 over, tell me the answer on Edmodo.